Hello, class 11th students. Today we will discuss the exercise 5.2. We want to find out the differentiation of the some functions are there. We know these functions are trigonometric, maybe algebraic, and you see this function. Differentiate the functions with respect to x in exercises 1 to 8. So x is the variable. We want to differentiate this function with respect to x. dy dx of this function, I just want to find out sine x square plus 5. Okay. Since you know that if we differentiate this function, we will get, you know, the integration dy dx of sine x. Dy dx of sine x equal to, you know, cos x. Okay, fine. So I will differentiate this one. So what we are getting? Sine, this become the sine become the cos, or you can say this is x square plus 5 and dy dx of this function x square plus 5, because we want to, because this is not x, until it will comes out x or 1 we will continue to do it. So now we want to do next. You see this one x square plus 5. See the x square, you remember this one formula, dy dx of x raised to n will be equal to what? N times x raised to n minus 1. Or you can say dy dx of constant 5. 5 is a constant. It will comes out 0, because there is no variable x in this expression. So we do this one, what we see, cos x square plus 5, and this will comes out integration multiplied. X square becomes 2 x, and this power, you can say 2 minus 1, 2 minus 1 plus 5 becomes here 0. So simplify this one, you are getting here cos x square plus 5 into, you can say 2x, 2 minus 1, 1. So write down the correct way, 2 outside, 2 x cos x square plus 5. This is the answer of this question. I hope you understand. So now I would like to do this question number 4. Differentiate this function with respect to x. So we say dy dx of sec tan, you see this one tan, this is root x closed, this tan x. All right. You know what? Since you know very well that dy dx of sec x will equal to what? Sec x tan x. Okay. So we start this one. So it will be comes out what? Sec tan root x. Okay. Then we have multiplied by, you say, the sec x tan x. Tan root x. See, this function is not ended, because you say this is not x. This is a tan root x is there. So we have to do the differentiation of that part also, multiplied by dy dx of tan root x. So now tan root x, we see that here what is the value of tan x is there. If you want to do the differentiation of tan x, dy dx of tan x will comes out, you know, sec square x. We have this formula. So using this formula, for that, these terms will remain same. Sec of tan, I will have to write down the repeat the terms, root x tan root x goes differentiation of this one. It will comes out sec square into sec square. This angle is that root x. See again, you see this one. This angle is not x is there. This is the root x. So we have to do the differentiation of that part again. Dy dx of root x. So root x differentiation will comes out 1 upon 2 root x. So I will write down here the sec tan root x into tan root x into sec square root x into the differentiation of root x will be say the half 1 by 2 into x raised to minus half. This becomes out 1 upon 2 root x. 1 upon 2. This is the answer. So now we are getting, this is the answer of this question. We are doing this one up to x. We are doing this one. This will be the answer. So I hope you understand this question. Now we want to do this question number 5. Want to differentiate this function with respect to x. So you say dy by dx of this whole function sine ax plus b upon cos cx plus d. So which formula we have to use? You say that this is quotient function we have to apply. There is two functions, one in numerator and one in denominators are there. So I will use the quotient function. You know that here that dy dx of u upon v will be equal to u v minus u v divided by v square. And here's very trick is that u dash and last v dash. U dash v minus uv dash upon v square. We have applied this quotient formula for this one. There is a u equal to sine ax plus b and v equal to cos cx plus d. If we differentiate this one, what do you see? Sine ax plus b. First, I want to differentiate this sine ax plus b. You know, again, the formulas are that dy dx. I will write down the dy dx. You know formulas. You know the formula very well that dy dx of sine x equal to what? Cos x. And dy dx of cos x equal to what? Minus sin x. We know this formula. We will use the formula here. So u dash comes out what? Sin ax plus b. Differentiation of sin ax plus b. This will comes out by using this formula. We say it is comes out cos ax plus b. And now, see, this is not x. So this is not x is there. So ax plus b is not the x. We will differentiate this one again. So we are getting a into v. V is here cos cx plus d minus u sine ax plus b. Now cos cx plus d, we want to differentiate this one. This will comes out, you can say with the minus sign. You see cos dy dx of cos x becomes out minus sign. If c is there, remember, if c is there, the sign will comes out minus. C like cot and cosec also comes out minus. So it will comes out minus sine cx plus d. And since it is not completed because this is a cx plus d, so it is further differentiated and we are getting into c whole divided by v square. V square is here cos square cx plus d. So now next line. Say this a is here. You say cos ax plus b. This cos cx plus d a, and sine ax plus b minus sine cx plus d dot c. Yeah, this is the answer. There's no need to further simplify. You may simplify or write on the answer way. A is a real number, so first we write on the A, better way. Cos ax plus b cos cx plus d. Only, but just we are doing the rearranging the terms are there only to so that the answer look good. Minus sign plus sign, and c is a real number, so take a constant outside. Sine ax plus b sine cx plus d. Only rearranging the terms only. Nothing else we are doing here. Cos square cx plus d. This is the answer of this question. I hope you enjoy and understand this question. Now, I would like to do this question number 6. Cos x cubed into sine square x raised to 5. See, in these questions, we want to do the dy dx of these terms. Cos, this angle is that x cube, okay, into this cos function is multiplied by sine square, okay, fine, square. And this angle is x raised to 5. So here you see, this is the two functions are there, this function and this function. This is a product of two functions. So we use the product rule, and the product rule says dy dx of uv equal to, write down here the uv plus uv, and with the u dash v plus ub dash. Okay. So now we use this product rules to solve this terms are there, because these two terms are product. This is a u and this is a v. So I will consider that it will be u and this will be considered as v. So it comes out. First we take the cos x cube, the differentiation of that cos x cube. It will comes out. Cos x cube will be, minus sine x cube. See, x cube is not completed. So it is again x cube will be differentiated. So we are getting here 3x square plus sine square x raised to 5. So this you say the sine, this not the sine function is that sine x5 in power n. The function power of some number is there. So we do this one 2 times sine x raised to power 5, and now sine x raised to power 5 is differentiated. We are getting here cos x raised to 5, and then again x raised to 5 is differentiated. We are getting here 5 x raised to 4. So now we simplify this one. In simplifications, what I did here, first we write down sign and real number outside. Say minus is there, 3 is there, so we write down here the minus 3. Then we have a algebraic numbers are there. I say I will put the algebraic first, then trigonometry. 3x square sine x cube plus, say the sign. Sign is here plus, there's no minus is there. 2 is a real number and 5 is a real number. 2 into 5 comes out 10. X raised to 4, we write on the algebra first. Then we write on the trigonometric function. Sin x raised to 5 and cos x raised to 5. You may also combine these two numbers, but okay, may I combine also these two numbers? Cos x raised to 5. So this is, you see the sin a cos a formulas are there. It become the sine of 2a formulas are there. I may combine this one, or I will leave out the answer here. So there's not too much affected are there. So I say this is the answer, and hope that you enjoy it. Or you may also simplify this one, like say the sine a cos a is there. Make a 2 sine a cos a will be equal to sine of 2 times x raised to 5. That is also possible. So may I also possible here, I can combine these two terms also. If I wish to do, okay, let's do it here. When I am saying this one, you may thought it, I am saying, I'll say 2 times sine a cos a become the sine 2a. So now we have a 5 x raised to 4 sine 2 times x raised to 5. I combine this one. So this is the answer. and come back on the next question. Now, I would like to do this question number 7. See, 2 times square root cot x square. So we want to do the dy dx of this question. 2 times this root is there. I write on this way better when is that 2 times you say cot x square raised to power half. We want to do the differentiation of that part. So what the formula we use first? So this simple one, already we have learned this formula. 2 is a constant taken outside. This is the product terms are there. So 2 in terms of multiplication has no meaning taken outside. Now we have this one formula. So which formula we will use here? dy dx of x raised to n, you know, n times x raised to n minus 1. So it becomes half. This function cot angle x square, it goes to power half minus 1 into, say this function is not x is there. Okay, fine. So we say that here we are doing not this x is there. It's not x basically. So you say that's one dy dx of this part. Cot, we write down here the cot x square angle, and we have closed this one. Right. Now, this 2 and 2 cancel out. And we see that here we are getting here cot x square, power goes to what? This cot x square whole function, power is minus half into dy dx of cot x square. Say, you know formula that dy dx of cot x. The c is there. C is a, when c comes out minus sign, minus cosec square x. Use this formula. It will comes out minus cosec square x. X is here. Here again the x square is there, not the x. Say this is not x. This is the x square. So we write down here the dy dx of that x square further. This terms you see this one goes to in the denominators are there. It may go in the denominator, or you will write down better. We write down here 1 upon minus half is there under root cot angle x square into this minus sign is there, no doubt, minus cosec square this x square dy dx becomes out what, say 2x. So finally I just want to write down the answer. It will comes out minus 2, because actually the minus sign is there, 2 is there, x is there. Now we write down the trigonometric function. You see that here cosec square x square divided by under root cot x square. So this is the answer. We may do the further trigonometry, but there is no need to do too much trigonometries are there until a question says. So now we will do this question number 9. Prove that the function f given by fx is equal to mod function x minus 1, where x belongs to real number, is not differentiable at x equal to 1. They say this is a modulus function is there, and I have to just find out whether this function is differentiable at this point x equal to 1 or not. So for that purpose we say that limit exists or not, left hand limit, right hand limit, and the function value. If these 3 things are equal, then we say function is differentiable, otherwise not. We say function is not differentiable, it means the limit. First we will find out the left hand limit. Limit x tends to 1 minus fx. Okay, what is the value of fx here? Limit x tends to 1 minus mod of x minus 1. Say h is less than 1. So this is a negative number. So this negative number, it will comes out, you can say limit, what is a function basically, x tends to 1 minus mod x minus 1 means, I just writing here, minus sign is there, minus x plus 1. Now we put the limit x equal to 1. We are getting minus 1 plus 1. You see x equal to 1 is here. X, put the value of x is 1, minus 1 plus 1, and that comes out 0. Right. Now we have to find out the second limit, x equal to 1 plus. Say not this way. I have to find out the function is differentiable. So we say the left hand derivative and right hand derivative. So first we find out the left hand derivative. Left hand derivative. Left hand derivative says limit h tend to 0, function of c plus h. Here the x is there. X, we say we a point is 1 is there. C plus h, c plus h minus function of c divided by h. If we say h is tending to, here we say 0 minus. Okay. C is here, here you say that here C is here, C is here 1. We say that here we want to find out the value of 1. So we say limit h tends to 0, function of 1 plus h minus function of 1 upon h. Okay. So we are taking here the limit is that this h is tending to 0 is there, no doubt. So what the function will comes out? Function of 1 plus h, mod of, put the value here, mod 1 plus h. H equal to, we say h. So if say 1 plus h minus h, this becomes the mod of h. 1 plus h minus 1 minus function of 1, mod of 1 minus 1 divided by h. So this comes out what? This 1 and 1 cancel, 1 and minus 1 cancel out, mod h. We say the limit is also here, limit h is tending to 0 minus. So we have limit h tends to 0 minus. So this function becomes basically mod h minus 0, has no meaning basically, upon h. Say h 0 minus, h is negative. So this function becomes basically limit h tends to 0 minus h upon h. The function is limit h tends to 0 minus 1. So value comes out minus 1. So left hand derivative of this part will be, you can say, minus 1. Now we have to find out the right hand derivative. Right hand derivative. Limit, now h tends to 0 plus. In the previous case, it's going to 0 minus. Now we say that 0 plus. Function of h, no, this is c plus h. C is a point. Function of c plus h minus function of c divided by h. You put the value here. The same function is that limit h tends to 0 plus c plus h. The function, you can say c is here 1. The function will becomes out here 1 plus h minus 1. The same function, the value here, minus 1 minus 1, 1 minus 1 divided by h. So the function becomes, we say, limit h tends to 0 plus, this is mod h upon h. So limit h tends to 0 plus, the function will be here h upon h. That cancel out. Limit h tends to 0 plus, the value is 1 here. So it will comes out 1. So you see that here right hand derivative is right and left hand derivative and right hand derivative are not equal. Left hand derivative, the value is not equal to right hand derivative. That's why the function is not differentiable at h equal to say 1.